Bohr's work came earlier before the mathematical derivation that proves that matter can have a wave characteristics. This makes Bohr's work all the more remarkable. The mathematical proof that describes the particle-wave duality was proposed by de Broglie. This is called the wave-particle duality hypothesis. Prior to this work, scientists were able to explain the spectrum of the black body radiation. This feat is accomplished by Max Planck. Later, Einstein was able to show that light can have momentum. Merging these two concepts lead de Broglie to hypothesize that there is a wave and particle duality. We will give you the proof starting with Planck and then followed by Einstein's photoelectric effect and then de Broglie's mathematical proof that the wave-particle duality is possible. According to Max Planck, the energy related to the radiation is given by the formula, E is equal to hf, where h is the Planck's constant and is equal to 6.62 times 10 raised to the negative 34 meters squared kilogram per second. And f is the frequency of the source. Now, we go to Einstein's derivation for the relationship of energy and relativistic momentum, because these waves are traveling with that of the speed of light. We use the definition of momentum, P is equal to m times v. And by Einstein's formula, energy is related to the momentum using the expression, E is equal to momentum P times c, where c is the speed of light. Relating frequency to momentum is like claiming that wave can have momentum and thus exhibit particle nature. This is done when we equate Planck's equation for energy to Einstein's formula for energy. We have, hf is equal to pc. Solving for the momentum p, we have, p is equal to hf all over c, where c is the speed of light. We can relate momentum to the wave's wavelength using frequency. We can use the formula, v is equal to the wavelength times the frequency f. Solving for the frequency will give us velocity divided by the wavelength. Plugging this into the formula for momentum, we have, p is equal to h over c times velocity over wavelength. We note that v is equal to c because electromagnetic waves travels in the speed of light. Therefore we have, p is equal to h over the wavelength. And the wavelength is related to the momentum using the formula, h over p or h all over mv. We can apply this to the electron. The smallest path traveled by the electron in the hydrogen atom would be the circumference or the orbit itself. We can equate the wavelength to the orbit and find out that the wavelength is equal to 2 pi r. We can now write 2 pi r is equal to h all over mv. And if we rearrange the terms and solve for the angular momentum of the electron in the hydrogen atom, we will find out that mvr is equal to h all over 2 pi. Mvr is called as the angular momentum. The angular momentum of the electron in the hydrogen atom is constant, because it is equal to the Planck's constant over 2 pi.